All right, your last two examples in this infinite limits lesson is really just a quick Algebra 2 review about how to find vertical asymptotes. Notice that you have two rational functions to deal with. So when you're looking for vertical asymptotes, you want to basically look to see where is your denominator equal to 0, and then can you remove any of those factors? So the numerator, x squared minus 2, does not factor. However, your denominator, x squared minus x minus 2, does factor, and I do need to see what those factors are. So that would be x plus 1 and x minus 2. All right, so as we think about what we were talking about before, can we remove either of those factors? Since the numerator was prime, we cannot simplify anything. So we actually do have two places where that denominator is equal to 0. So the first would be when x plus 1 equals 0, and that would be when x equals negative 1. And then the second would be where x minus 2 equals 0, and that would be when x equals 2. So those are two non-removable discontinuities, and the graph for those would be vertical asymptotes at x equals negative 1 and at x equals 2. And you would need to have those stated using the x equals, because they are vertical lines, and that's how you name a vertical line. Now, looking at part B, you have your numerator, h of x equals, for x squared minus 4, you can factor that. That's a difference of 2 squares. And so we'll factor that into x plus 2 and x minus 2. Now your denominator, which is x to the third plus 2x squared plus x plus 2, now that has 4 terms. So just a quick review on factoring for that. 4 terms, x to the third plus 2x squared plus x plus 2. Group the first 2 terms together. You can take out an x squared, leaving x plus 2. Your last 2 terms, you could take out a positive 1, leaving x plus 2. X plus 2 is your common factor, so it'll be one of your factors, and then x squared plus 1 will be the other factor. All right, so looking at this example, we can remove x plus 2. So that's a removable discontinuity that happens at x plus 2. And there would actually be a hole in the graph at x equals negative 2. That's not what this question asked about. It asked you to find vertical asymptotes. So now we'll look at the remaining factor, x squared plus 1, from your denominator. It is non-removable. However, actually, it's a non-removable factor, but we're going to find out that there's no discontinuity going on here, because x squared plus 1 cannot equal 0. You get x squared equals negative 1, and over the real number system, that is not a real number. And so we have no factor that is causing us to have a 0 in the denominator that is a removable factor. And so therefore, this function, even though it does have a discontinuity, it does not have a vertical asymptote. So no vertical asymptotes. So I want you to get the idea that discontinuities that are removable are not are holes in the graphs and not vertical asymptotes. You're looking for those non-removable discontinuities that cause 0 in the denominator. So that'll be the end of video 3. And remember to work on your homework and ask any questions as you have them.